Welcome back. Now let us learn one of the important concepts, image filters. So what is the meaning of filters? Filter means applying some kind of visual effects to the image, and once you apply, you may get different outcome. And what are those outcomes? Blurring, detecting edges, sharpening, enhancing image contrast, eroding, dilating. All these terms I'll be defining in a detail in the code just before doing these things. And I'll explain these things using the both scikit image and OpenCV. And in scikit image I'll give you the basic one, and in OpenCV we'll go a little bit more advanced. How does these things happen? This happens through convolution. And those who have taken in a deep learning course, as I had explained earlier, that if you have taken any deep learning course, any deep learning from anyone, then you must be aware of what is convolution. Okay. If not, then I'll brief. Anyway, I'm going to brief you little bit over here so that you do not left out. If you do not know, no problem. I'll try to explain in a very simple English so that you understand what is the meaning of convolution. From definition point of view, it is a mathematical operation that is performed on two functions to produce a third. And what are those two functions? The one function is that this, like if you see, this is your image, and another function is something called kernel. Kernel is another matrix. So this matrix is a simple matrix, and you will see when we define the kernel. So what is the process for this one? This process for this one is, let me explain this. Please open the file miscellaneous.xls. This file is there in your code folder, miscellaneous.xls. Please open this file, and here I have done it. See, I've just tried to give some example. Let's assume this is your image, where 0, 0, 1 and everything is there, and this is the all are black, and this is the only one pixel is white. And you have a kernel. Kernel is another matrix. This is a kernel. Okay, and the sum of this kernel is 9. So I am dividing by 9 so that it become 1. If you don't divide by 9, it will make it more white. So just for timing, you trust me that we must normalize it to make it final as in 1. Okay, so how does this thing happen? If you see, for any pixel, this gets done in this way. So I'm just trying to show you. So for this pixel, what it will do? It will put this matrix on top of it. How does this does it? It will multiply this 1 with this 0, this 1 with this 0, this with this 0, and so on. It will multiply everything and then sum up. If you see, whenever you multiply 1 and 0, everything will become 0 except this one. So 255 into 1, that is 255, and then divided by 9. That is what this value will be there. So after these things, the value of this 255 will come down to 28. So initially it was a pure white. Now it has become a little blackish or one of the gray color. This happens for each and every pixel, and this is what the convolution does it. So this is after one convolution. So through convolution you can achieve blurring. If you see, this effect was a blurring because here we had a white and we have blurred it. Okay, and you can do the edges. I will explain you detail that how you can really detect edges, how can you sharpen, how can you enhance image contrast, eroding and dilating. I will explain these things in the code, because if I explain everything now, probably you may forget this. Okay, so I'm not explaining. So if you saw that the way I have explained you, multiply the pixel under the kernel by value in the kernel. What is the meaning of that? All this pixel, that image pixel, gets multiplied by this kernel. Okay, here we had, this is the kernel, this part, and then sum those results, sum, that is fine, and replace that pixel with the summed value. So this is what we have done it. This is done for everything. Here just for simplicity I have kept only one. Okay, I have just kept only one for this pixel. This is what the convolution is all about. Okay, and the image filters are a few types. Linear filters like mean, Laplacian of Gaussian, and non-linear filters median, maximum, minimum, Sowell, Prewitt, Canny, and all these things I'm going to explain in the code. I'm not explaining right now. During the code I'll explain you. I'll also give you that why there is so many filters, what are the pros and cons, in which situation you should use which one, and why there is why so many filters have been invented, why not only one, and so on. So those parts I'll cover in the code, so nothing to worry about. Again, just to let you know, we'll be covering filters in both scikit-image and with OpenCV, both. In OpenCV we'll go in much more in advanced way, but in a much more basic way we'll go with skimage. Okay, thanks a lot for watching it. See you in the next one.